Hello, so today we are going to look at using inequalities to define shapes, our polygons, and our coordinate plane. So just going to do a couple of examples. It says determine the system of linear inequalities that have been used to create each shaded polygonal region. In each case, the vertices are given to assist you. So here I have some vertices. I'm going to go ahead and, for my purpose, I don't know if you need this. I definitely need this. I need to see the vertices. And I'm going to actually, after I finish doing this, we'll flip over to our free graphing calculator at www.desmos.com to make sure that we did everything correctly, okay? So first we have -20, -10, and I'm going to guess that that is this point right here. So that's -20, -10, because this is the negative x and the negative y. Then I have 30, -10. So 30, -10 would be right here. Okay. And then we have -20, 15. So -20 will be over here. And then 30, 15 would be over here. Now, the way that these are all straight lines. They're all vertical and horizontal lines. So I'm going to use my knowledge of VUX-HOY, and that's my favorite acronym to help me remember how to define lines, horizontal and vertical lines. V stands for vertical, U is undefined slope, X is going to be on the x-axis, and it looks like the equation X equals 2. H is horizontal line, O is really going to be 0 slope, and Y is going to be, the equation is going to be Y equal 2. But in this case, we're doing inequality, so it's going to be an inequality instead of equal to. So the first, I'll look at this line here, and this line is a horizontal line. So when I have it like this, this is horizontal, so it's going to look like Y equal 2. So that means I'm going to use my Y value, and my Y value is 15. And so that's Y. Looking at this, I need to be less than. So it's going to be less than, and the line is shaded, so less than or equal to 15. The next one is also my horizontal line, and so that means it's going to be Y equals 2 again. So I'm going to look at my Y, and it's -10. And this time I want everything above it, so it's greater than. So Y is greater than or equal to -15. Next, we'll look at this vertical line here. And this vertical line is seeing the X, so that's 30. So X is going to be going in this direction, so it's less than or equal to 30. And then we have here, we have the X again, so that's X, and this time we're going in this direction, so X is greater than or equal to -20. All right, so let's pull up our graphic calculator and put these equations in. Okay, so I've already written them in here for us to see. I'm going to click on them one by one, but I would just put in Y, my less than, and I hit the equal sign, and then 15. And I'll do that really quick. So we have less than equal to 15. Oops. And so I'm going to click on this so you can see it. And so that's going to be everything, since my Y equals 15, everything below here. Y greater than -10, that's everything above here, so that's the orange. Then we have X, so 30 should be everything going this way, and it is. And then 20 is going in the opposite direction. So this is the gray area. On Desmos, it allows me to kind of these are the solutions, but just to show you how to use Desmos, in case you wanted to know, I went ahead and also included some additional constraints to make it where everything else is not shaded in. So I know that I want my X to be between -20 and 30, and my Y to be between -10, and you can't see it. Let's see if I can open it up a little bit. -10 and 15, right? So those are the constraints. So if I turn on those constraints, you'll see those things are highlighted. And I just have that box there. And so that's what the box represented in our PowerPoint lesson that we just did. Okay, so let's do another one. Okay, so this time we have a actual line that we'll have to find, which makes it a little bit more challenging, which is okay because we want to make sure that I'm not leaving anything out and you get to see all different types of examples. So the first one is I'm going to plot my points. So I have negative 30 and negative 15. So I'm assuming that that is this point here, negative 30 and negative 15. To help me visualize. And I can also plot these points in decimals too if I need to, if you want to. And I'll show you that when we get done plotting here. Then we have negative 30, 25. So negative 30 will stay over here. 25 will come up here. So that's negative 30, 25. Then I have 40, 10. So I'm going to have to assume that this is, no, that's probably not. I'm going to have to assume this is 40, 10. 40 would be more over here, wouldn't, don't you think? I'm going to have to say yes, 40 is probably more over there. So this is probably 10, 20. Oh, yep, because we have 25 up here. So the 10, 25 is up here. So we have this one, and this one. Now we'll do 40. Yeah, 40, 10 would be probably here. And that makes sense because this has to be 40 and negative 15. So let's do the easy part first, which is using my vertical and horizontal lines. So the easy part first would be to look at this vertical line first. So this vertical line is V, so it's the X. So that is going to be X is, my X is negative 30. It's going to be going in positive direction, so it's going to be greater than or equal to negative 30. We have another one here, another vertical line. So that's going to be X, and we have less than this time, less than or equal to 40. All right, so now we have a horizontal line here, and that horizontal line is at Y, and it's greater than everything greater than or equal to negative 15. And then we have another horizontal line right here, and that's at 25. So Y is less than or equal to 25. All right, so now we just have to find the equation of this line, and that should not be a problem at all because we have 2 points. And if we have 2 points, we can find the equation. So first we'll find the slope. And so we'll do 25 minus 10, 25 minus 10, my y's, over 10 minus 40. And that makes sense. It's going to come out negative. So that's going to be 15 over negative 30, which is negative 1/2. Like I said, it makes sense because if I'm looking at it as I'm going down the hill, it is negative. It's going in a negative direction. As I look at it, it's like I'm reading a book. I said going down the hill, I'm sorry. If I look at it like I'm reading a book, it's going down the hill, so it's negative. So negative 1/2, so that slope makes sense. And then I need to find my y-intercept. So it doesn't matter which one of these points I use to find it. I'm going to use, let's try 10, 25. So we'll say y, which is 25, and I'm using y equals mx plus b, by the way. So 25 is equal to 10, which is my x. I'm sorry, and my m is negative 1/2 plus b. So negative 1/2 times 10 is going to give me 25 is equal to negative 5 plus b. I'm going to add 5 to both sides. And I get b is equal to 30. So that gives me an equation of y. I'm not going to put the equal sign. Well, I can go ahead and put it. We can change it later. And I'm going to move it down here actually, so it can be next to my other system of equations. So y is equal to my slope, which is negative 1/2 x plus 30. And so if I look at it, it's negative, it's going down. So that's going to be less than. So we'll say less than or equal to negative 1/2 x plus 30. So let's put that in our graphing calculator. Okay, so I'm here at my free graphing calculator, Desmos, www.desmos.com, and I've placed the inequalities, or the system of inequalities, here in my calculator. So I just unhighlight them. I'm going to highlight them again. So x is greater than or equal to negative 30 is this line down here. Going to show up. Oh, sorry, x is a vertical line. I apologize. So that's negative 30. X is less than or equal to 40, and so that's going to be over here, everything here. Then I have y is less than or equal to, greater than or equal to negative 15. So there's everything shaded up there. And y is less than or equal to 25. So starting here, everything down. And then we have our line that we created, which was y is less than or equal to negative 1/2 x plus 30. And so there's that line. And notice this time I only made one for my Desmos calculator to kind of show how everything is captured off. All I needed was those constraints, which were the high and the low and the high of my y values, and the low and the high of my x values, which I just pulled from the things that I got here. So I'm going to unclick all of these so that you can see what it looks like when I have it highlighted. So here's that box, and this is the same box that we had in our presentation, and I really and truly hope that this helps.